Good afternoon and welcome to today's HydroCAD webinar. My name is Peter Smart. I'll be presenting this afternoon's session, and today we're going to be talking about land use analysis and pollutant loading in HydroCAD. These are two related features, but they can actually be used separately. That is, you can do just land use reporting on its own for various purposes and then enable the pollutant loading calculations as a separate feature. The pollutant loading and reporting capability was added in HydroCAD 9.0. It's available in all versions from 9 onward. We also will be talking a little bit about the ability to import land use information from an Autocad plan. That's another capability that was actually added in HydroCAD 10. It's an enhancement to the process. HydroCAD 10 also gives you the ability to configure specific active ground covers within your project. So there are some other capabilities that were added. If you happen to be using something between version 9 but not up to 10, then you will not see all of those features. So there's a range of different capabilities here. Let's start first by talking about just the land use reporting component of this element. In a minute we'll talk about the related feature of defining pollutants, pollutant concentrations, and actually doing the loading calculations. But we do have the ability to do land use analysis and reporting separately. So I have a sample project I want to open up. You could use most any project you already have to do this with. The process would work much the same. If we take an existing project, and what we want to do is go to the screen for Settings Land Use, which has this little house icon next to it. And you'll find the same icon over on the right-hand toolbar. And if you hover over that, it'll give us a tooltip indicating that this is the land use settings. So if we click that box, we come to the land use settings screen. And the first thing we want to do is to enable this top box to report land use. Now, when we do that, HydroCAD is going to automatically check the current file that we have open. And it's going through all of the subcatchments and their subareas, and in this case it's finding that none of the subareas, 17 of these subareas, do not have existing land use assignments. We have ground covers which are being used to do the curve number assignment and runoff calculation, but the land usage, that is the actual activity that occurs on the ground, is undefined. So when we turn on land use reporting, it's giving us this option to automatically preset the land uses for each of those subareas based on the default settings that are in our ground covered lookup table. And we'll look at that table in a little while and see how that works. But at the moment we just have this option as to whether to preset those. In general, you will want to answer yes here because you don't want blanks in all of those boxes. You can always go in and make changes to those assignments at a later time, so you're not locked in by doing this, but it avoids having an empty assignment for those areas. So let's say yes, we do want to set the default land uses for those areas. At the moment, we are not going to select the box here for pollutant loading. We'll come back to that in a minute just to show how the two capabilities can be used separately. But if we come to the next tab up top for land uses, we now have a table which is showing us all the land uses that are defined in our current ground covered lookup table. So these are standard land uses that are pre-assigned. There are various ways that we can change and even customize these land uses, and we'll be looking at that. But these are the standard land uses that are set up. If we wanted to set up a custom land use, then it's really quite straightforward. We can just scroll down to the bottom of the table, and we could do something like add warehouse to the end of that list as a custom land use. The actual land uses that you will use will vary depending on the specific purpose of your analysis, and if you're doing pollutant loading on the specific categories which your local regulations prescribe. In some areas it may be relatively specific, such as the samples shown here, but in other cases you may have just a couple of very basic categories, such as industrial, residential, and commercial. Again, it will depend entirely on what your regulations are. Also, keep in mind that you can use this reporting capability for essentially any kind of reporting that you want to perform on your project. You don't have to use this in conjunction with the pollutant loading. So you could simply map your ground by color as to whether it's red, green, or blue, and use red, green, and blue in your land use table here, and you would get reporting of the acreage in each of those categories. So it could be used for a lot of different purposes. It's not limited strictly to the pollutant loading that we'll be looking at. But more commonly, you will be using it with your pollutant loading calculation, and what you're probably going to be doing is customizing this land use table in order to represent the land uses that are actually present within or actually going to be used within your current analysis. So we can now click OK on this box to accept that list of land uses. And now if we were to open up a report for any of the nodes within this project, we would see the additional reporting on land usage. Let's go to subcatchment 1S and double click that and open a report window and come to the Summary tab and expand that. And we've now got some additional information that's visible in this report. Up at the top of the report, here we have a table showing, as usual, our areas and curve numbers and the ground cover description. And it's important to keep our terminology clear here. By ground cover, we are talking about the actual cover on the ground. That is, it's grass, or it's paved parking, or it's rooftop. As opposed to the land usage, which is essentially the activity that's occurring on top of that ground cover. And our pollutant loading, when we get to that, will be associated with the land use. So what we're seeing here is that each of these ground covers has a pre-assigned default land use, which is appearing in this adjacent column. There's no other changes to this pond or subcatchment summary by virtue of having turned on the land use analysis. All we're doing is seeing the land use assignment for each of those given ground covers. Now, if we come to the project-wide report up on the toolbar, we have a couple of new tabs that appear here. The first is for ground covers. And this one, actually these are the standard ground covers, excuse me, this is not the new land use covers, but this report is not changed when we turn on the land use reporting. But if we go to the next tab here for land use, now we have a list that shows the land uses that are actually in use somewhere in this project. And it's showing us the total area of each land use that's occurring, and then a list of all of the subcatchments which include part of that land use. So cropland is occurring only in 4S, industrial only in 1S, etc. But woods, we have some amount of woods in 2S, 3S, 10, 11, and 22. And this is the total area of those subcatchments, which of course should match the total area that we have right here when we look at the ground cover analysis. Okay, so a new tab appears for land use analysis and simply shows us the acreage. So this is an example of how you could set up land use assignments, and you could in fact use this for other reporting capabilities, and it would show you which subcatchments these are present in and give you a report of the total amount of each of those categories present within the project. Now, if we were to edit this particular subcatchment that we have open, let's come back to the subcatchment report and click the Edit button. And on the Area tab, this table has now been expanded with an additional column. Over here on the right-hand side, we have a land use column. This is only visible once we've enabled the land use reporting within this specific project. And you can see here for each line in the lookup table, together with the ground cover that we've selected, is the associated default land use. If we were to double-click any one of these lines, which will take us to the lookup table, you can see that the additional column is also present here. Normally this is hidden if you're not doing land use analysis. If land use analysis is enabled, you'll see a column which contains the default land use for that particular ground cover. So when we come through the table, and if we were to scroll down here and pick one of these residential district lot sizes, for example, you can see that all of these are categorized as residential in terms of the land use analysis. So you can come through this table and see how they're set. For example, all of the crop ground covers, the large list down the bottom, are all categorized as cropland. And if we were to select a line there, then it comes in with that ground cover. And in this case, this is an interesting thing to see, that it's actually preserving our previous land use setting. So what I need to do is actually go to a brand new line here And if we pick the new ground cover, you can see that cropland comes in here. We have this ability to manually adjust or change the default land use that's assigned. So if we come over to this box and click land use, we're now able to select any of the land uses that are pre-configured for this particular project. So this allows us to pick a given ground cover, and perhaps we don't want that categorized as cropland. Perhaps we want that as open space instead. We can make that change for that individual subcatchment and individual sub-area. Now, if you're always going to want to change the assignment, then that's something we can do separately on a Watershed Settings screen. But when we edit the subcatchments, we have this ability to just make the changes right here on the screen. If we click OK, you will see that our report gets updated, and we now have the additional areas that have been entered. For example, this cropland, which is coming in now as open space. It's been recategorized. So this is the basic process for going through and using the land use reporting capability. And again, you'll see this on the subcatchment reports and on the project reports. Now, the next thing you may want to do to fine-tune your land use reporting capability is that if we come to the Watershed Settings screen, you'll find this in two places, under Settings Watershed, and then the little tree icon also appears on the right-hand toolbar under Configure Watershed. So we click this box. This screen is something new that was added in HydroCAD 10 that gives us the ability to fine-tune the ground covers that are going to be used in a particular project. By default, all of the lines in this ground cover table are selected. The checkbox is set on every single line. And you can scroll through the table and you see they're all checked off. The first thing we can do on this screen that's of interest is that we have the capability to uncheck specific ground covers that we do not care to use on a particular project. So this will reduce the table that's available to you when you do your subcatchment entry and remove basically the superfluous entries that you don't want to accidentally select within that project. So one of the things we could do is we could come to the bottom here and we could click the Select None button, and that will deselect everything. And we could click Select Active. And what this does is it finds the ground covers that are currently being used in this particular project, and it checks those off. So this is very handy if you've got an existing project and you just want to enforce rules for that project that only these ground covers should be used when any future changes are made. Then you can use Select Active. And so now if we OK this and come back and edit our subcatchment and go to the lookup table, this lookup table has now been trimmed and is only showing the specific categories that are active within this project. Now let's come back one more time to the Watershed Settings screen, because this also contains a column here for the land use. This column is only activated when the land use reporting has been enabled. And this shows us the default land use that's associated with each ground cover. All of this information, by the way, is stored in a ground cover file. This is the default file, the cn020.txt, which is pre-installed with HydroCAD. And that's what you're going to be using for most of your projects. There are also capabilities here to set up custom ground cover files and actually custom override files, which is a very handy way to be able to make specific modifications to a standard ground cover file without replacing the entire file. And that's definitely the approach we recommend if you find you want to customize the file, to do an override file instead. The reason for that is that then all of the core default information will be preserved, including any changes that may be made in a new version of the software. So if we add additional ground covers, they will still percolate through and be available to you. Whereas if you replace the entire file with your own custom file, you won't see any of that new information that may be added. So an override file is the recommended approach. If you click the Help button on the screen, it will give you detailed information about the entire screen and how it operates, including discussions of setting up override files and exactly when you would use those and how you would construct them. Now, one of the things that's very powerful here, in addition to selecting the custom ground covers, is that we can use this screen to change the default land use that's associated with any given ground cover. So if we were to come down, for example, to this cropland setting and double-click that, we can specify an override. We can use a drop-down list here, and we could indicate that we actually want cropland to be categorized just as open space for reporting purposes rather than the separate cropland category. And you'll notice that the override is shown here with curly braces around it. Anything here with braces or brackets indicates that it's an override item. And there are boxes here that we can use to clear all the overrides on the screen, or even save these overrides to a file that we can then use as an override file. We also have the capability to import settings from another project and bring them into the screen. So there's a whole bunch of different capabilities. But basically we can use this to customize the table. So now that particular crop cover is actually categorized as open space for reporting purposes. If we were to click OK and come back in, and let's edit another subcatchment, and if we scroll down our table here to cropland, you can see that these row crops are now categorized here as open space rather than cropland. And the curly braces appear here as a reminder to you that this is an override within this particular project, that it's not actually using the default settings straight from the ground cover lookup table. So we would select the line off this table and put in an area, and we've now picked a ground cover with a custom land use assignment. So that's the process of setting up the land uses and customizing the land uses. Now what we want to look at is the more common scenario that we're going to be doing a pollutant loading calculation instead. So we need to turn on that additional option for pollutant loading. Before we do that, let's just talk a little bit about how pollutant loading calculations are performed. And we can get this information in a couple of different places. We can go to the HydroCAD help system, and we can look up pollutant loading here. We can also pull up the HydroCAD owner's manual, and there's a PDF version of that available as well as the printed copy, and that is actually on page 129, I believe, in the HydroCAD 10 manual. This section 23 discusses land use analysis and pollutant loading. The content here is very similar to what's in the help system. And then finally, we also have the online web page, which discusses the same topic, and you'll find a lot of the information here. The key, what we want to look at, is how the pollutant loading is actually being calculated. And the key to this process is a very simple equation to start with. We are taking the runoff depth from a given area of land, which is R, and then multiplying that by the pollutant concentration, C, and by the runoff area, A. And once we adjust the units appropriately, this gives us a total loading, a weight of that particular pollutant. So in order to do the pollutant loading calculations, we need these parameters. The runoff area is pretty obvious. We already have that. The pollutant concentration is a parameter that we're actually going to enter, so that's an input parameter. And then we need the runoff depth. And there are a couple of different ways that we can determine the runoff depth in order to do pollutant loading. One of the very commonly used procedures is the simple method. And the simple method is a procedure which essentially estimates the total runoff depth, usually over a fairly long period of time, such as 1 year. So that rather than just looking at the pollutant loading for a single event, we would look at annual loads for this watershed. HydroCAD, of course, is typically used for modeling an individual event, and we're using that for peak flow calculations and for pond design and other such relatively short-term purposes. But the pollutant loading, although we can do pollutant loading on an individual event basis, it's more common that we want to do that on an annual basis or some other long time period. And that's where the simple method comes in. The simple method is a procedure for estimating the total runoff depth that will occur for this particular watershed over a longer period of time. And again, it's a relatively simple equation. And what we're doing here is we are determining the total runoff depth based on a precipitation depth. So this might be the total precipitation for a year for this particular site. So perhaps this is 40 inches, 50 inches, something in that time range. And then we'll multiply that by an adjustment factor for the fraction of the rainfall events that actually produce runoff. And this is usually about 0.9, 90%. So we're saying that most of the events produce some runoff. And then finally there is a runoff coefficient, an RV. The runoff coefficient is in turn determined based on the imperviousness of the watershed. And with the simple method, this is the equation that is used to estimate imperviousness. So we are taking the fraction of the total runoff area which is impervious, and HydroCAD is assessing this by looking at the curve numbers within the project. If your curve number is 98 or higher, then that area is considered to be impervious for the purposes of this calculation. If it is less than that, then it's considered to be a pervious surface. So HydroCAD uses this to determine the I, the fraction of the runoff area which is impervious. This is then used in equation 101 here in order to determine the RV value, the runoff coefficient. And from that we can now finally determine the total runoff depth R, which we're going to plug back into our loading equation and get the total load L. So a couple of simple equations that are piggybacked together. There are a number of articles you can look at on the simple method to read more about this, and you will find those on the web page that we have. There's also some information on the HydroCAD Owner's Manual. If you were performing this calculation by hand, you would typically roll these previous equations together and use a single equation and group all of the runoff coefficients together. And so now we have are able to use the more traditional units together, even though they're apparently mismatched. For example, our pollutant concentration is milligrams per liter, but we are doing pollutant loading in pounds, and our precipitation depth is in inches, and our area is in acres. So you can see it's a muddled set of parameters, but you can plug them all together into this equation with this factor of 0.2266 in order to get the final loading in pounds. When HydroCAD does the calculation, it's adjusting all of the units automatically. You won't actually find this coefficient of 0.2266 within the HydroCAD calculations because everything's being converted to the current unit system that your project is set for. So that's the overall process of doing the loading calculation. So now let's come back to HydroCAD and look at how that's actually set up and how the calculations are calculated. So we can close out of the manual and out of our help screen at the moment. And let's come back to our watershed, or rather not our watershed settings screen, but our land use settings screen. On the land use settings screen, you recall we'd enabled the land use reporting. Now what we want to do is we also want to enable pollutant loading. When we turn on pollutant loading, we have several additional options that appear on this screen. The first is this box in which we specify how the imperviousness is going to be calculated. And you'll need to look very carefully here at your regulations to determine the appropriate method for your project. There's a little bit of ambiguity in the simple method in that it doesn't really specify whether we are going to do the imperviousness for the entire project under study, whether we should do impervious for each of the land uses, whether we should do it for each of the subcatchments, or whether we should do it for each land use and each subcatchment. So there are some options here, so you'll want to look at this. In most cases, I'd suggest you just stay with imperviousness for the entire project, but these other options will produce slightly different results depending on the details of the site you're analyzing. For each of these first four options, what we need to do is we need to specify the total rainfall depth that we're going to analyze. So this is commonly going to be your 12-month rainfall depth. So this would be the depth for an entire year. It could be for a week or a month or 10 years, whatever you choose. Just keep track of the time period that that depth represents. And then there's a correction factor. Your regulations will have some suggestions as to what this should be. 0.9 is a common value, indicating the fraction of the rainfall events that actually produce runoff. So this is the minimal amount of information we have to set up in order to define the pollutant loading. Then we have to go to the Land Uses tab. On Land Uses here, we have the land use categories that we've already set up, but we don't have any pollutants yet. So there are a couple of ways we could set these up. We could come down here and click Add Pollutants, and then we can specify the individual pollutants that we want to use in this project. So, for example, we could put in TSS for total suspended solids, and now a column appears for TSS in milligrams per liter. So we can now come to each of these categories and each of the land uses, and we could specify what the pollutant concentration will be for that particular pollutant and that particular land use. And then we can repeat this process. For example, we could put in a column for total nitrogen, and we could put in a column for total phosphorus. Whatever pollutants you wish to study, you can define those on a project-by-project basis. And then you would specify the pollutant concentrations for whichever land uses you wish to use in that project. Now, once you already have a project which is set up with the appropriate pollutants and their concentrations, the easier way to configure this screen is to click Import Pollutants. And we can now go to your previous project, which is already set up, select the project, and this is just going to give us a warning here that it's going to replace all of the current pollutant information in this project. And so now the columns and the concentration values have all been updated for this particular project without having to re-enter everything. So once you get that information configured for the particular site or county or state in which you're doing these studies, you won't have to re-enter that. You can just import it on subsequent projects. So now we can do OK on the screen in order to save this additional information. And if we come back and double-click a project report, or rather a subcatchment report, and look at the summary and scroll down right to the bottom, we now have an additional section which has been added. We still have the table here showing the land uses that are assigned with each of the ground covers. And then down the bottom we have a new table showing the actual pollutant loading calculation. Now the first line on this table tells us that the pollutant loading is being calculated for 42 inches of rainfall, the total depth that we've specified, and that this correction factor is 0.9, that 90% of the rainfall actually produces runoff. On the next line you can see that we're calculating imperviousness on a project-wide basis, and the total imperviousness is 5.2% for this entire project. This produces a runoff coefficient of 0.097, and this translates to a runoff of 3.66 inches. So if this 42 inches total rainfall for the year is translating into 3.66 inches of runoff for the purposes of our pollutant loading calculation. So this is the simple method essentially in these two lines. It's converting that 42 inches of rainfall to this runoff depth. This runoff depth is completely independent of the runoff that's actually being calculated by HydroCAD at the moment for this particular event. The simple method is looking at a longer time period. HydroCAD is looking at a single event. We can switch this if we prefer, and we can do the pollutant loading for an individual event, in which case this runoff depth will exactly match the depth that HydroCAD is predicting for the subcatchment. So both of these options are available to you. The simple method was developed so that it could be applied separately without having to do all of the detailed hydrograph runoff generation, which is being done in HydroCAD. But you have the ability to use it separately as a simple method or with the actual runoff numbers. That choice is up to you. So finally, we have a table at the bottom which shows the area for the subcatchment. So up top, we have a total of 38 acres, and we should have exactly the same acreage down here, which we do. And this shows us a breakdown of how that is distributed between the different land uses. And if you were to come up to this table and tally each of these, you'd get the totals that are shown down below. So that's the process of getting the area for each of the land uses. And then we have a column which shows the pollutant loading in pounds. So for total suspended solids, phosphorus and nitrogen, it's giving us the total load on each land use, and then finally the loading for the overall subcatchment. And as you would expect, that information is then carried over and is available to us in the project-wide report. So if we open up the project report And we have tabs here first for land use, which is much the same as it was before. It's just the land usage. But we now have a tab for pollutants. And this is showing us the information that we put in on the pollutant setup screen. We have each of the land uses, and then we have the pollutants that have been defined and the specific concentrations of each pollutant for each land use. Then we have additional tabs, which we can see more easily if we expand this window. We have a tab for subcatchment loading. So this is showing us for each subcatchment in the project what the loading is for each of the pollutants that are defined. And then, of course, the total loading. This total loading here should agree with the loading that's also displayed on the project loading report. If we come over here, we have now an analysis that shows us for each particular land use what the loading is project-wide for that land use. This table also shows a number of additional parameters. Here's our imperviousness, and you'll notice that it's the same for every single land use. And that's because we've specified in this particular case that the imperviousness is to be calculated on a project-wide basis. If we were to change that and calculate it by subcatchment or other means, then we would see this imperviousness change. Similarly, the runoff coefficient is the same for each land use because the imperviousness parameter is being used identically throughout the project. Same with the runoff number, the depth of 3.66 inches. So we can view the loading information in several different ways here on a subcatchment by subcatchment basis or project-wide. So that's the basic process for setting up and using the pollutant loading calculation. We can, of course, customize any of this information. So if we wanted to change pollutant concentrations, we could come back to our land use settings, come into land use, and we could change the total suspended solids for croplands and click OK, and all of our reporting is updated automatically. So everything carries through for you. You can change the concentrations or even the pollutants at any time. And remember that importing your pollutants from an existing project is the easiest way to set those up. Once you have a project with the specific pollutants for that area, then you can just import from there. Let's go back to a couple of the other calculation settings just for a moment. If we come in to actually the land use settings screen is what I want, and we can look at the options here for imperviousness. If we change this and select actual runoff, for example, you'll notice that the boxes are now grayed out for runoff depth because it's going to use the actual runoff number that comes from HydroCAD. We click OK and come back to our project report window, and the available tabs have shifted because of the different nature of the calculation. We still have the land use listing. We still have the pollutants we've defined. But now the subcatchment loading, or the loading, is being calculated on a per subcatchment basis because the runoff is naturally calculated for each subcatchment. So now HydroCAD is using the actual runoff for the subcatchment in order to determine what the loading will be for the specific event. And if we come into the subcatchment and double-click that and look at the summary and come down to the bottom here, you can see that our loading here is being calculated for 1.82 inches of runoff, which is the specific runoff depth for this subcatchment. So it's pretty straightforward. Things will reconfigure automatically in these reports as you change the options. If we use any of these other imperviousness options to calculate imperviousness by different subcategories, then you'll see slight changes in the report and how that's set up. One more thing I want to mention here before we wrap up is that there's also the capability to import the land use information from an AutoCAD drawing. This is used in conjunction with the capability to import all of your sub-area information. So if sub-area information has been configured, then we can bring all of that, the land use, in as well. This is done on the Watershed Setup screen. We would come over to the Import Settings tab where we configure our CAD import capability. We have separate sessions that discuss this in detail, but just to note that although this is most commonly used to bring in just the ground cover and curve number information, we can also have an additional layer which includes the land use assignments. So once this box has been selected, for example, and we come back to ground covers, we now have an additional column which shows the layers that are defined or to be used for each of these ground covers. And scrolling way down to the bottom here, we have this layer which is being used for the land use assignment. So we have an additional 2 layers actually, one for the land use boundaries and one for the land use text. So this enables us to simply draw those additional layers, and HydroCAD will do the cut-through process so that now we don't have to have default ground covers associated with each, or default land use associated with each ground cover. Instead, we can just map the land use, so we can have a fully independent assignment of the land use mapped on our project. So it's a very powerful capability, and you can pull all of that information in together. Or, of course, you can do the manual entry as we have just done here in HydroCAD. So that's a pretty complete look at the pollutant loading and land use analysis capabilities in HydroCAD. Again, keep in mind that you can use the reporting separately if you want to do that. You can also import this information from an Autocad plan if you wish to. At the moment, HydroCAD is doing just the pollutant loading calculation. As of HydroCAD 10 anyway, there's no pollutant routing or removal within the model. That's something that we're looking at for a future release, which would probably allow you to enter the removal efficiency for given structures, for given nodes within your project on a per pollutant basis. This again would be based on your local regulations, and then the model would be able to actually route the pollutant loads through the model. But for most cases, it's sufficient to get the pollutant loading that's present for the project, and then you can use that to design your BMPs. So thank you very much for joining us today. We will have a recording of this session posted on our website later today, so if you want to view it again or others in your organization have questions, you can have a look at that. And as always, feel free to send any questions to support@hydrocad.net, and we'll be glad to help you out. Thank you. I hope we'll see you at a future session. Have a great day. Bye-bye.